Non-homogeneous equations, the reduction of order. This time we are going to find the general solution of the non-homogeneous equation, where the solution y1 of the associated homogeneous equation is known. Recall y1 and y2 are linearly independent. That means y1 over y2 or y2 over y1 is not a constant term. So we let y2 be u times the y1 or the known solution of the homogeneous equation. Example 2. Use the method of reduction of order to find the second solution y2 of the homogeneous equation and the particular solution of the given non-homogeneous equation. Recall the solution of the non-homogeneous equation is in the form of the sum of yc and yp. Yc is the solution from the associated homogeneous equation, and yp is called the particular solution, and yc is C1, Y1 plus C2, Y2, which is the linear combination of the two solutions of the associated homogeneous equation. First of all, let y be the function u times the known function y1. In our case, the differential equation y double prime plus y prime equals 1, where y1 or the known solution is 1. Therefore, the general solution y equals u times y1 is u multiplied by 1 or just u. Y prime is the same as u prime. The y double prime is u double prime. Now we are going to substitute y prime equals u prime, y double prime equals u double prime into the original differential equation to get u double prime plus u prime equals 1. And next, we let w, which is another function, equal u prime. Therefore, w prime is u double prime. And then substitute into the previous equation. At this point, this is the second order. After we substitute, u double prime is replaced with the w prime, and the u prime replaced with w equals 1. Now we have the first order, or the linear equation in terms of w. Since this is a linear, we are going to use the linear formula to find the solution w. Is 1 over mu multiplied by the integral of mu times f of x dx plus c. I'm going to put as a c1 as we have more antiderivative coming out. So for this linear equation, the p of x equals 1, and the f of x equals 1. The mu, or the integrating factor, which is e to the integral, the p dx, which is e to the integral 1 dx, or e to the x. Therefore, the w equals 1 over e to the x multiplied by the integral of e to the x multiplied by 1 with respect to x plus c1. That gives us 1 over e to the x multiplied by the integral e to the x with respect to x plus c1, or 1 over e to the x multiplied by e to the x plus c1. We write it as 1 plus c1 e to the negative x. Recall w is u prime. So now we have u prime equals 1 plus c1 e to the negative x. Next, we're going to find u. Since u prime is 1 plus c1 e to the negative x, u is the antiderivative of 1 plus c1 e to the negative x with respect to x. That gives us x minus c1 e to the negative x plus another constant of integration, c2. Recall the u is the function y1 multiply by, I'm sorry, the u is the same as the general solution y. Non-homogeneous equations, the reduction of order. Reduction of order can be used to find the general solution of a non-homogeneous equation. Whenever a solution y1 of the associated homogeneous equation is known. So we are going to use the reduction of order to find the y as the sum of yc and yp, where yc is the linear combination of the solution y1 and y2 of the associated homogeneous equation. Y1 is given, or the Y1 is known. So we are going to find out the rest of the solution, which is form the general solution of the non-homogeneous equation. Y1 and Y2 are linearly independent, therefore Y2O Y1 is not constant term. So we are going to treat Y2 as the product of the function U and the known solution Y1. Example 2. Given the differential equation, which is the non-homogeneous equation, and the first solution, we are going to find the general solution of the non-homogeneous equation, which is in the form of y equals yc plus yp, or c1 y1 plus c2 y2 plus yp. Let y, or the general solution, as the product of the function u and the known solution y1. In our case, y1 is 1, so u times 1, or just u. Y prime is the same as u prime. Y double prime is u double prime. Now we are going to substitute y equals u, y prime equals u prime, y double prime equals u double prime into the equation. We have the equation in terms of u as u double prime plus u prime equals 1. And this is still the second order. Next, we're going to let w be u prime. Therefore, the w prime is u double prime. And then substitute into this equation to get w prime plus w equals 1. Now we have the first order equation, which is linear. To solve the linear equation, as you recall, the solution w is 1 over mu multiplied by integral mu times f of x dx plus c. I'm going to put as c1. In this case, the px equals 1, the fx equals 1. So the mu, or the integrating factor, is e to the integral px dx, or e to the integral 1 dx, which gives us e to the x. So the solution w is 1 over e to the x multiplied by the integral of e to the x multiplied by 1 with respect to x plus c1. That means we have 1 over e to the x multiplied by e to the x plus c1. Rearrange the term, or multiply 1 over e to the x to the two terms in the parentheses. We have 1 plus c1 e to the negative x. We call w is u prime. Now we're going to solve for u. U equals the antiderivative of 1 plus c1 e to the negative x with respect to x, which is x plus negative c1 e to the negative x, and then plus c2. At the beginning, when we started with the y equals the u times y1, and it turns out to be y equals u, therefore our solution, or the general solution of this non-homogeneous equation y, which is the same as u, in the form of the x minus c1 e to the negative x plus c2. And in the pattern of the solution of the non-homogeneous equation, which is y equals yc plus yp, and yc is the linear combination of the first solution and the second solution. So from the solution that we obtain, if we rearrange it, we have negative c1 e to the negative x plus c2 multiplied by some function which is 1, and then plus x, the term that contains the constant c1 and c2. Those are the terms that contain the solution of the associated homogeneous equation. From the given information, the y1 equals 1, therefore the second solution of the homogeneous equation, or the associated homogeneous equation, is e to the negative x, and the x is the particular solution. Now we get them all. So y1 equals 1, y2 equals e to the negative x. Those are linearly independent solutions of the associated homogeneous equation. And the yp, which is the function without the coefficient as the parameter c1 or c2.